Hello and welcome to this presentation. My name is Matilda Gibson. Today I'm going to be talking about the focuses I would use to teach a STEAMS lesson. I will firstly talk about STEM, then I will go on to talk about STEAMS, which incorporates arts and spirituality into STEM. I will then talk about some of the soft skills aligned with STEAMS. And finally, I will go into an integrated STEAMS project aimed at stage 2 level that incorporates all areas of the STEAMS. STEM is an educational learning area that incorporates 4 educational disciplines. These 4 educational disciplines are science, technology, engineering, and mathematics. All 4 of these are interconnected and can be applied to a lesson. STEAMS is slightly different. The STEM subject area has 4 educational disciplines, while STEAMS has 6. The addition of the creative arts and spirituality allows for teachers to teach the STEM disciplines from a biblical worldview, allowing their students to express their learning artistically. The soft skills aligned with STEAMS are important for student development, not just in the subject area, but in all other areas of life. Teachers need to support their students' development of these skills so they can be successful learners. These skills include critical thinking, creativity, collaboration and teamwork, problem solving, and resilience. I will now go into my Stage 2 level integrated STEAMS project. It is really important for a teacher to clearly identify the values and aims of a project before they begin the planning process. The values and aims of this project are that students can begin to think about and show how they can care for God's creation, that they can understand the negative impacts of waste on animals and of the environment, that they can act on the identified issues that they have brainstormed in the classroom and make differences in their contexts. Additionally, inquiry-based learning can support the development of important skills for life, including the discussed soft skills. This project applies an inquiry-based approach by posing critical questions to each step of the learning process. This will help students to think critically about the world around them. It is important to make all learning applicable to what is surrounding the student. So this project focuses on issues that arise in the students' lives on a daily basis, this being the concept of waste. The focus of this project will be waste management, and the focus question will be how can we develop waste collection systems to enhance waste management in our classrooms. Throughout the project, students will identify the issues of waste in the world and in their classrooms by looking at animals and the environment and the impacts of waste on those 2 factors. They will design ways to control waste in their classrooms and at school. They will collect and analyze data, design posters, create projects and implement their work, and then evaluate and reflect on what they have come to. As students progress through the phases of this project, they will develop understandings aligned with waste and its impacts on the environment. They will examine the effects of waste on living things. They will link their understanding to the world around them and their contexts so they can positively influence the world around them. They will collect information and data on their classroom's waste consumption and creation so they can compare their data with each other and make predictions. They will be challenged to design systems to solve problems, especially aligned with their consumption of waste and creation of waste. They will create and implement designs and models and everything aligned with their problem solving. They will analyze and compare past data from the beginning of the project to future data or current data that they have collected after they have solved problems, and then they will reflect on their project and reflect on its ability to solve the issues aligned with waste. This project is formatted based off the 6 phases of design thinking. These phases help to create a very thorough project that considers all areas of design thinking. Part 1 of this project is emphasize. In this phase, students will be posed with a range of inquiry questions that will enable them to understand their waste contributions and the implications these have on animals and the environment. They will discuss the waste they make in a day and collect all the non-organic waste that they accumulate throughout the school day. They will make predictions of how much waste they individually contribute and all together as a class. They will then graph their waste on a column graph and analyze their data. Additionally, they will analyze the waste management systems at school and record their findings. Part 2 of this project is define. In this phase, students will be posed with the overarching question of how can they manage waste more effectively in their classroom. This lesson will be dedicated to brainstorming solutions to the problems discussed in phase 1. They will identify the different categories of waste and how to dispose of them. Students will then map out ways they can dispose of all these waste categories in creative ways. They will also discuss the role of reusing certain waste materials. Part 3 of this project is ideate. This phase will be dedicated to discussing and collaborating in groups to decide on the best ideas for waste management. Each group can be given a different waste category and can think of unique ways of storing and disposing of them. In their groups, they will present their best ideas to the rest of the class, and their peers can provide them with feedback that will fuel decisions toward which idea will be the most practical for waste management. Part 4 of this project is prototype. In this phase, students will begin putting their ideas to practice by designing and creating prototypes for their classroom waste disposal units. This lesson will be hands-on, and students will be drawing, molding, measuring, designing, painting, planning, recording data, and discussing their ideas in their groups. They will also sort out the finer details like costs, resources, materials, posters, and functions toward the actual building of the disposal unit. Part 5 of this project is the test and share phase. In this phase, students will use either laptops or iPads to design a PowerPoint presentation in which they will explain their model to the rest of the class and receive feedback on their prototype. They will record this feedback and discuss implementing as much of it as they can. After they reflect on the feedback they have received, they will work in their groups to make a plan for the building of the waste disposal unit. These will be built in the next phase. The final part of this project is the implementation and reflection phase. This phase will be dedicated to implementing plans by collecting materials, building in groups, completing the disposal units, creating posters for the disposal units, and disposing of their waste correctly. Over time, they will record their results and the effectiveness of their units in achieving their goals. They should be constantly reflecting on their results and adapting their systems to be most practical. The spiritual underpinnings of this project are limitless. From a biblical lens, students gain an understanding of God's hand in the creation of the world and are reminded of His current presence in His creation. Genesis 2:15 calls humankind to care for creation. As students progress through this integrated STEAMS project, they will learn to protect and care for creation by managing their waste and disposing of it correctly. As they do, they will aim their hearts closer to God and His calling on their lives. The subject area of science is heavily incorporated throughout this integrated STEAMS project. Students are learning scientific concepts as they investigate the impacts of waste and rubbish on the environment and animals. They are encouraged to take scientific field notes as they explore the waste management systems around the school, and as they interact in discussions about waste, they are learning about environmental issues and how they can act to make a difference in their community. In this project, students have an opportunity to develop their technological skills by working on personal devices to create PowerPoint presentations and posters for their disposal units. Over time, their understanding of different practical applications will grow, and they will understand how they can use them as a tool to achieve their goals. Care should be taken, though, to ensure students are being safe as they research images over the internet. Engineering is a skill that students will develop mostly in the fourth phase of this project. As they create prototypes and drawings, their engineering design skills will develop. By the time they are actually to build the disposal units, their practice in the prototype and designing phase will enable them to be more successful. These skills are important for life, and this integrated project will give students a fun opportunity to develop them. Art is an important part of this project. The skills aligned with art are foundational for success in the design, prototype, and building phases of this project. Students will create many different forms of their disposal units. These include drawn form, modelled, prototyped, and full form. Additionally, they will create posters to provide information aligned with their units. Without visual art skills or digital art skills, students will have less success in these areas. This integrated STEAMS project provides many opportunities for students to apply mathematical skills to their investigations. As they progress through the phases of the project, they will collect, analyze, arrange, and interpret data, make mathematical predictions, measure materials and spaces in the classroom, and many more. The options for working mathematically in this project are vast, and students will be able to apply their skills to real-life situations. As teachers aim at providing formative assessment for their students, they can use many strategies that work well throughout the learning process. A teacher can observe their students during discussions, planning periods, and group tasks, monitoring students' participation, collaboration, and engagement. They can also pose open-ended questions to gauge students' comprehension, critical thinking, and ability to apply concepts related to waste management and environmental science. Students may also be helpful in assessing one another. Teachers may encourage students to provide constructive feedback to their peers during group work, presentations, and discussions, focusing on communication, problem solving, and teamwork skills. Finally, timely feedback directly from the teacher can enhance the learning process. For assessing scientific outcomes, teachers can provide students with scientific investigative prompts in handout form so they can go and collect information of their waste usage throughout the day. Once they have collected this data, teachers may assign students with graph templates in which they can arrange their data and interpret it with numbers and compare it with their peers. From a mathematical assessment perspective, this will help them assess students' proficiency in creating and interpreting graphs by analyzing the clarity, accuracy, and relevance of their graphical representations of waste data. Additionally, teachers can assess their students' ability to plan out scientific materials, tools, and equipments that they need by giving them group handouts to fill in. This will enable them to prove their ability to select and use materials to solve environmental issues. Teachers may assign reflective essays or journal entries where students can articulate their understandings of waste management concepts, reflect on their learning process, and identify areas for future exploration or improvement. Finally, students can be assessed by their ability to create artistic designs, drawings, models, and prototypes by photographing their work from the prototypes and the finished product. These outcomes listed are all outcomes that teachers can formally assess using the integrated STEAMS project. Thinking back to the soft skills that the STEAMS approach can foster, this project enables students to develop all of these skills. In regard to critical thinking, students are posed with complex questions that encourage them to critically analyze their own actions and how they impact the world around them. They will be enabled to investigate widespread issues aligned with waste and brainstorm waste management strategies in groups. These opportunities are foundational for students to develop critical thinking skills that they can use throughout their entire lives. All areas of this project enable creativity. Through planning, brainstorming, designing, building, collaboration, and presenting, students are given the reins to drive their own creative path and build their understanding creatively. Throughout many of the phases, group work, collaboration, and feedback are important for success in the project. As students progress, they will be required to work alongside peers and build them up constructively for success. Problem solving is heavily incorporated throughout the project. Each phase contains inquiry questions that drive the students toward problem solving in unique ways. Finally, students will grow in their resilience as they work in groups, receive feedback, and face challenges that may set them back. Support from the teacher and peers will be important for success throughout the project. Thank you for listening.